is Thomakos. You can find me on internet-related sites at Thomakos. And today I want to talk about how we've gone about replacing Active Record in our Rails application. I work at a company called Strava. We're a social network and training site for athletes. We do really cool stuff with GPS and other data that you might generate during your runs, rides, swims, or other physical activity of your choice. I also like running, especially outside. I have a dog named Barney who runs with me. He can keep up despite being 9 years old. I also live in the San Francisco Bay Area, and Strava is based there, and we are hiring. You by no means need to be a runner or cyclist to work at Strava, but it does help if you like nice weather. So, as you may have guessed, we use Rails at Strava. Our Rails app started its life over 8 years ago as a Ruby 1 application, and Rails 1 application, we were using Ruby 1.8.6. Today, it's evolved into a monolith. It's a Rails 3 application that we're in the process of upgrading to Rails 4, and we're running Ruby 2.3.3. The app contains approximately 400,000 lines of Ruby code, but that doesn't include a lot of gems that we've extracted over time. That number also doesn't include a lot of services that we've extracted out of the app over time as well. And our Rails monolith still interacts with all of these services, but it's just no longer responsible for all of that logic and all that code. So today you'll get pretty mixed opinions if you ask a Strava engineer about Rails, but the reality is that Rails has enabled us to get to where we are today. Especially in the early days, Rails allowed us to iterate very quickly and develop new features very quickly. Over time, this has definitely become less true. And to be fair, the problem isn't all because of Rails. A lot of what we do is just more difficult because we have more data, and we have more users, and we have higher standards for uptime and maintainability. But the reality is that the Rails way isn't really optimized for us any longer. As our application has grown, just doing things the Rails way has led to code that's difficult to work with and difficult to maintain. A few of the reasons for this one of the reasons for this is that Rails favors kind of a global view of everything. Almost every object you create in Rails is available everywhere. And the APIs that these objects inherit, or the number of methods that the Rails DSLs generate, are very large, and they result in very flexible objects that are difficult to manage. The other problem is that the Rails way is understandably inherently tied to Rails. And that might actually not be a problem if Rails upgrades weren't so painful. And upgrades have definitely gotten better since version 1, but they still take a long time to roll out smoothly, and they're very costly in terms of developer time. So today I want to talk about the active record subsystem of Rails, because this has been a major cause of pain for us. Our active record objects are littered throughout our code base, and they're particularly challenging to deal with when we need to refactor or when we need to upgrade Rails. So I want to tell you about how we've tackled these pain points by stepping outside of the classical Rails way of doing things. So we often think of active record as persistent stuff, but we know that's not the end of the story. Active record objects have so much more going on than that. So as an example, one of our active record objects at Strava is a bike, which represents a bike that an athlete might use during a ride. It has a few relationships to other objects, and this isn't a big list. Bikes are relatively simple, but our athlete object, what you might typically call a user in most applications, has around 65 of these declarations. The bike model is also responsible for validation, which can get pretty complex with the introduction of complex conditionals and custom conditionals. The bike model is also responsible for callbacks, and I've been using Rails for over 8 years, and I still don't remember the order in which these things run. Like, do my after save callbacks run before or after my after create callbacks? What if I change the order in which I define them? Do my after save callbacks run after I destroy or not? I was still not sure about that one. So it's not always obvious, and especially for new developers, that, for example, most of these callbacks run before the database transaction is even committed. And callbacks can also become additionally complex with conditionals. Active record objects also have scopes, or custom queries, that are exposed as part of their public API, and these can be combined with scopes from yet more active record objects to form even more complex queries. It can be very difficult to search a large Rails code base for uses of these. So bikes can also be used in non-obvious ways. This use of includes is not due to a particular method that we defined on bikes, but it's possible because our bikes and our athletes objects are related. This means that the public API of active record objects extends much, much further than just the methods you define on them. Active record relationships can be chained to pass along attributes for creation or read or delete. And this code is easy to understand once you're familiar with Rails and once you understand that there's kind of a foreign key relationship that's passed along through the create call. But even then, this pattern is difficult to find and maintain. So if you can reason about all parts of your app at once, these particular cases may not matter yet. But at some point, you're going to get to that 53rd or 59th minute where everything's all of a sudden going to double, and it's not going to be possible for you to reason about your app completely any longer. To top it all off, our bike active record object also has a bunch of helper and view and business logic methods. Because we use these objects everywhere, these are also particularly difficult cases to find. So this is a list of some of the responsibilities we've covered, and they all live in a single object. So unsurprisingly, all in all, our instances of our bike class have around 400 methods, and this doesn't include all those kind of hidden relationships that we talked about. So the promise of good object-oriented design is that any one object is digestible, that I can read it and understand what it's responsible for, the messages that it's sending, even if I don't fully understand all of its collaborators. Our bike active record object definitely does not live up to these standards. Our athlete object is even worse. It has over 2,500 methods. And a lot of these methods exist just because the public API, the API that active record objects inherit is huge. So all of this came to a head when some developers started asking if we could just use the active record object, but maybe not include the relationships, or maybe not add the validation, or not add the callbacks, or not add the scopes. And it was clear that we were trying to avoid the active record way of doing things, and we needed some better, newer practices moving forward. So we came up with this project called the No AR project. And No AR literally means no active record. And I wish now that we had a snappier or fancier name. There probably is a better name, but the framework I'm going to tell you about literally describes the process for removing active record from your code base, so the name is actually kind of appropriate. So the way we approached this problem was to look at all the responsibilities of an active record object and try to break them down into separate objects instead. It's certainly difficult, right? If you look at this list and think about the case of creating a new record, we definitely have to deal with persistence because we want to save the record to the database. And we want to validate our input parameters, so we also need to handle validation. And once we've written the record, we need to execute some callbacks. So we aren't going to avoid that responsibility either. So at least for the create, update, destroy operations, we're stuck with these three things. And that's still a 50% reduction in responsibility, but it's a lot for a single object to be responsible for. So let's assume for a moment that we take each of these responsibilities and split them up into separate objects instead. We'll use one object that takes an attribute hash and writes it to the database. We'll create another object that maybe validates the attribute hash, maybe raises an exception with error information when attributes aren't valid. We'll also use a collection of other objects which are responsible for executing callbacks like event logging, sending welcome emails, cache busting. Of course, we still need to tie all of these together somehow, so we'll come back to this. We also have a similar but simpler case for query operations. To get rid of scopes and relationships, we'd like to flatten our API to the few method calls that we actually use. Instead of chaining objects by their relationships or scopes, we can flatten that API to a few methods that we actually need for querying. That way, we remove all those extra uses of bikes that are difficult to find and replace them with single method calls instead. So let's come back to the helper methods a little later and stick to these responsibilities now because they're all tied with basic CRUD operations: create, read, update, and destroy. Assuming we split all these responsibilities into separate objects, we still need to tie them together. So let's start there and figure out if it's a valid strategy. We like to think of the glue that holds these CRUD operations together as a service. It's a pretty generic term, but each service is well encapsulated. It exposes a flat public API, and as the name service implies, services can communicate with each other through their public APIs. I'm going to tell you about the service architecture that we've used and how it's allowed us to eliminate active record. So each of our services lives in the Strava namespace. This helps us not conflict with existing gems or any new namespaces that might be introduced in Rails. Service names are pluralized by convention, like bikes. And each service namespace has an additional actions module underneath it. Actions are the public API of a service. They're the query and command operations that a service exposes. So the creator is responsible for creating data. The reader is responsible for querying the service and retrieving data. The updater for modifying existing data. And obviously the destroyer for removing data. So you might be asking yourself, Why don't we just have a set of top-level methods like create, update, and destroy? And that's certainly a matter of preference, but we've found it easier to work with these methods when they're isolated in their own namespaces. We also tend to expose multiple APIs for each action type. So we could load a bike, but we also might be interested in loading all the bikes that belong to a particular athlete. So this separation allows us to create smaller classes that are a little bit more manageable. So let's try filling in a create action with a little more detail to see how it works. This is a simplified example of the bike creator, and I'll walk through it to show you what's going on. So the first thing the action does is delegate validation off to another object. As I was saying earlier, this object's responsible for validating the attribute hash. Maybe it raises an exception if something goes wrong. We then call off to the persistence layer, and we tell it that we want to persist our data to the database. Right now, I'm going to continue using active record here, which is a bit problematic, but we'll come back to the persistence stuff later on. We then perform our traditional callbacks like event logging, cache busting, sending welcome emails, whatever we might need. Finally, we're just going to return the ID of the object, and it's up to the caller if they want to load the new bike data from the database. There's some good reasons to not return an active record object here. The first of which is that we want to avoid using active record completely, but we also want our eventual implementation to be a little bit simpler. And active record does a lot of work to guess what you wrote to the database. And there are cases where the values of your active record objects actually do not represent what's in your database. So we just want to avoid those possibilities and that can of worms altogether. We're just going to return an ID here and keep things simple. So this might seem like a lot of responsibility for one object, but let alone one method. But this method actually doesn't do very much. It just delegates work. And we try to make sure that our action objects only delegate tasks instead of doing any part of those tasks themselves. So there's some key differences in how we might implement this with active record. So the first is that everything is in one place and in one order. It's very clear that event logging happens before cache busting. I don't need to know the relationship between after save and after create callbacks to understand that both of these callbacks run after the bike has been created. We don't have to go searching through an active record file to piece together the life cycle of this operation. Our code is more explicit and is well ordered, and this has definitely been a big win for us. So this is definitely progress, right? Assuming we're strict about using these new objects, we have much smaller APIs than we did with active record because we're only creating the methods that we need and want to support. If we apply this practice to all of our CRUD operations, we'll never find any of this code in our code base again because the athlete to bike relationship and consequently this API will no longer exist. All of our creates will go through a single object and a small set of methods. If active record changes, we'll be isolated from those changes. And if we're going to turn off writes to the bike service for some reason, we know exactly where that code path is going to converge. But we're not quite there. We haven't fully isolated ourselves from active record. We're still a little leaky. We still need active record to handle persistence. The problem is even more striking if you look at a possible reader implementation, which I kind of glossed over a little bit on purpose, because we haven't dealt with persistence. And we depend on active record to read from the database, and active record queries return active record objects. So we need to go further, because at this point there's nothing to stop a developer from using our reader action to just grab an active record object and modify our service data directly. So let's see if we can go deeper and design some really simple persistence objects. Some objects that are better encapsulated and have much smaller APIs. So I'm going to introduce you to our solution to this problem. We'll start out with what we call entities. So you can think of these objects as records, but we tend to avoid that term to avoid any confusion with active record. The bike entity lives inside the bike service. And the idea is here that entity objects will replace active record as return values. And they can't be used on their own to perform any operations against our service. These entities are easy to define with a few method calls that are provided by a basic entity class. I'm not going to go into detail about how the basic entity is implemented. I want to instead talk about the API of these entity objects and their properties. So the class level methods of an entity act as a small blueprint for how we want to retrieve data from the database. For instance, we can retrieve the database table name, column names, primary key, that kind of information. The actual entity instances have no database references whatsoever. They're simple data or struct-like objects. Their APIs are very, very small, especially when compared to that 400 plus line bike active record object. They're also immutable, which means that they actually represent data in the database and not some intermediate state. So let's see how we can plug these into a persistence layer. So all of our persistence lives in the DB namespace inside the service. And our DB namespace also mirrors the CRUD operations, just like the actions namespace does. A DB reader might just look like this. So in this case, we're actually inheriting all of our functionality from a basic entity reader. But before I dig into those details, let's also notice that in the initializer, we're passing in an entity that we want to populate. So remember that entity object has table, column, and primary key information on it. So let's step into the entity reader and see how this all hooks together. Bam, wall of code. Bear with me, it's not that complex. It's actually all that's required to replace active record. So first off, we make extensive use of the entity itself. Because the entity contains database kind of metadata or blueprint information, we can use it to construct some basic queries in a very generic way. When we need to retrieve data from the database, we also create entity instances that we return to the user instead of returning active record as a return value. The second thing you might notice is that we're injecting a database engine. And this could be something as simple as a MySQL2 or Postgres connection pool object. And we inject the engine for flexibility both in our code and in our testing. The engine includes information about which database partition or shard we're targeting. And having control over this value makes moving tables from one partition to another easier because we can simply inject a new value here. We're also using Arel internally. And Arel is a relational algebra gem that's used under the hood by active record. On this line, we're actually creating a new Arel table using the table name that we retrieved from our entity class. When the find method is called, we can use Arel to generate a where clause. And in this case, we're matching the primary key argument against the primary key that we also retrieved from the entity class. Arel also allows us to easily construct select clauses using a project method. And in this case, we're mapping over the database columns, again, provided by the entity. Using an entity with fewer columns means that we can tailor our select clauses to a subset of columns that we're actually interested in retrieving, which means that we can write more efficient SQL queries. Finally, we hook all the components together, all of our query components together, and generate some raw SQL to pass off to the database engine. We don't want to write string MySQL queries when possible. It's not very safe, so we use Arel internally. And you could just as easily use the SQL gem or some other Ruby to SQL relational algebra gem of your choice. So a lot of this is boilerplate functionality. Every developer on your team does not need to be intimately familiar with these details, but I'm hoping this example illustrates how simple it is to create some pretty basic and generic safe persistence objects. So if we step back out to our bike database reader, we can now build on this functionality to create more complex queries that are specific to our service. For instance, when we want to actually load all bikes that belong to a particular athlete, this kind of query building is easy to accomplish. It just takes a little getting used to the new syntax. We can do something similar with our creator as well. The DB creator is an entity creator, just like the DB reader is an entity reader. And this, again, allows us to do some basic setup. I'm not going to dig into the details again. But we also pass up the entity object to the entity creator, just so it has access to all that same database metadata information. So in the create method, we aren't doing anything special. When we receive a create call, we just add created at and updated at timestamps to our attribute hash. And then we pass that attribute up to the entity creator as well, which also uses Arel to insert data into the database and generate a new primary key that it returns. So we have these entity objects and these persistence objects. Let's take a look at plugging them into the actions that we talked about earlier. So if we look back at our creator action, we were using active record to persist the data and return an ID. We can now replace those calls with our DB creator, and we don't even need to deal with an entity object here because the creator always returns a new primary key. The reader is even simpler. We take our existing active record calls, and we just replace them with DB reader calls, which return instances of our entity class. This code might seem overly simplistic. Like, why don't we just call the DB reader methods directly? Well, we actually intentionally hide persistence details behind service actions. We don't want developers to go directly to the database because the persistence layer might change. And in fact, the persistence layer changing is something that we have had to deal with multiple times. So we want our actions to be gatekeepers. We want to be able to clearly specify the developer API that interacts with our data. So by isolating our persistence inside a service and behind a constrained API, we've moved away from that hyper-flexible global active record approach. No one service knows which database table another service is persisting to, or even if another service is using a database at all. Because our APIs have been pared down, we have fewer methods that return simpler objects. And we've gotten rid of active record, at least for all of our CRUD operations, which means we've accomplished a relatively high level of framework isolation in the process. So why is that a good thing? Remember, Rails upgrades are expensive, and we want to keep upgrading our Rails app to take advantage of the routing and WebSocket and asset pipeline and Webpacker improvements in Rails. And the more isolated we are from that complex and sprawling active record API, the easier the rest of those code changes become. We've also readied ourselves for extracting code from the Rails monolith if we decide that's appropriate for this set of CRUD operations. Hiding our persistence layer inside of a service is an excellent way to ensure that that transition is going to be easy when it actually comes up. So we're still missing some methods. When we look back to our original responsibility list, we dealt with all but one of these responsibilities. So we still need to deal with the helper methods from all those active record objects we removed. So we're going to talk about that next, just to tie up the loose ends. If you remember back to the bike active record object, we had some methods that looked like this. The first method is a hidden CRUD operation for retiring a bike. Basically, that means that we sold the bike, or we're never going to use it again. Maybe it's a broken bike. And most likely, we'd move this into our updater action. It's a pretty simple CRUD operation. These next two methods are kind of classic helper methods. They help us determine if a bike is a mountain bike as opposed to a road bike or a time trial bike based on the frame type. So what do we do with them? In most cases, we simply refactor this logic into plain Ruby business objects that we can use and test in isolation. We use entity object data to make these calls, but we don't call the functions on the entity objects directly. So that takes care of those helper methods. And in fact, these helper methods tend to be the easiest to move around. You just need to spend a little time figuring out where new methods belong. Okay, so let's bring this all back together. I'm going to quickly walk through this new object structure, and I'll tell you about the challenges and wins in undertaking this project and encapsulating everything inside nice little services. So we started out with full active record objects with relationships and validators and callbacks and scopes and helper methods and lots of other stuff in there. We extracted our callbacks into methods that live outside of a service namespace, like logging and cache busting and sending welcome emails. We added some validators, and we tend to keep these validators in the service because if we ever extract that service, the validators are likely going to go with. We also added some persistence objects and some simple immutable structs that we call entities, which we can replace our uses of active record as a return value with. We tied all these objects together through the service actions, which are responsible for delegating tasks to each of these other objects. Finally, we talked about strategies for those ad hoc or helper methods that live on active record objects. When we put all these objects together, we actually have enough to remove active record completely. So let's talk about some of the challenges and wins we've seen undertaking this project. Our largest, by far, ongoing challenge is that refactoring active record is difficult. Because uses of active record are hidden throughout our code base, we've actually resorted to a lot of statsd and custom logging calls just to find uses of them in production. But now, tricky uses of active record that are tied to class names or relationship names are no longer an issue because we have an entity object that is much, much simpler and cannot be used to turn around and alter a service's state. Our code is much easier to change, and our methods are much easier to find. But we've had to do a lot more kind of object-oriented thinking. And this is not a bad challenge to have, but it's definitely not as straightforward to write code without active record. We used to just throw new methods on active record objects, but now we have to spend more time thinking about where the methods belong and which object is actually responsible for a piece of data or a particular behavior. Without active record, we needed to write code now to save time later on. Active record is the opposite. We write code now, and we spend more time refactoring and untangling that code. That, for us, has been a big improvement. So one interesting win is that we no longer need to think in terms of a single database table. We can expand that definition of a service if it makes sense for us. This has been very liberating and has led to cleaner and more readable code. We may be operating on a single row in a single table or a collection of data stored in a service that we interact with through HTTP calls. This may seem strange, but we're taking a broader view of our data by adopting these service objects. And we aren't tied to a one-to-one relationship between model and database table any longer. This new framework is also conveniently very well suited to incremental improvements. We can replace a single reader call or a single controller action with minimal impact to the rest of the code base. And this is possible because we implement only what we need and because we have full control over our APIs. So we've gone from code that kind of looks like this, where we load a single object in a controller and then downstream in a view, trigger a bunch of associated SQL queries through these hidden relationships, to code where we've begun to chip away at our active record objects. And interestingly, our new code tends to pull all of those SQL queries together now. We don't have random SQL query execution happening while our views render. Because our APIs are simpler, we need to be a little bit more explicit in our code. Eventually, we want to get to here, where we've replaced all of our active record calls. This code is explicit, it's easy to find, it's well ordered, we can handle SQL issues in a single place. We can immediately see n+1 queries because we aren't accidentally executing them in some for loop in a view. And we can replace any one of these service data stores with an external micro or large service or whatever your flavor might be, service flavor might be, and the code will still work. So these small extractions from the Rails framework are often embraced due to their ability to make testing faster by virtue of just being isolated from Rails. And our tests are faster, and it's easier to use a TDD workflow now. But the real wins have been in some basic sustainability and scalability and readability of our code. We have more objects, but they each have way fewer responsibilities. They're smaller and easier to read, they're easier to reason about, and they're easier to change. Leaving active record behind means that we can actually take advantage of a lot more of what Rails has to offer sooner, because we can upgrade Rails with more ease and with higher confidence. Hopefully you can too. Thank you. My name is Pan. I work at Strava. We are hiring in beautiful San Francisco, and you can come work with us. Thanks.